soon enough, we're going to populate the internet with more AI profiles than we have humans. And those AI profiles will interact with you without you knowing, likely, that they are robots, and they will be your friends, right? So we're moving away from AI that act as tools to AI that acts as agents. So Gabriel, before we begin with the formal introductions here, I want to ask you, what is the biggest difference? One thing, one factor that people maybe omit. The difference between conversing with a human and conversing with a machine.
Yeah, I think one big limitation today with conversational agents is that you don't have the same kind of rapport and feeling that you have this rapid exchange of feedback and rapid turn-taking and conversational flow that you have with a human. So that's a limitation, and that's something that I work a lot on in my own research to try to improve that. But it's actually very, very hard. So I think that's something that most people would experience talking to an AI still, even if we have seen very big improvements. That's still a big limitation, I would say.
Mm-hmm. Fascinating. Looking forward to going deeper on all of that today. So to all our viewers or listeners, welcome to the Stockholm AI Street Talk podcast. My name is Leylani. I am the chairman of Stockholm AI. But more importantly, we have the big honor to have Gabriel Skantze with us today. He is a professor at the Royal Institute of Technology in Stockholm and a researcher in conversational AI and human-robot interaction. Areas of expertise focuses around how to make these kind of conversations work. Things like turn-taking, alignment, and grounding, and how robots should behave in a social setting, and perhaps even act as a partner, co-equal partner. Gabriel is also the chief scientist at Robotics. So let's begin there, Gabriel. Could you please take us back a bit and tell us, because you've been working on this field for a long time, and now it's everywhere, but it wasn't back when you started. So please tell us what drove you to say, this is the problem I want to solve, and this is the area I want to dedicate my research to.
Yeah, so I've been in this area for about 25 years now. So of course the technology looked very, very different back then than it is today, and actually very few people back then talked about it in terms of AI and so on. AI wasn't a term that people used a lot. I guess it was partly after all these sort of AI winters and so on, so people didn't have a very positive look on it. But I started by studying cognitive science in the 1990s, partly because I really loved computer science. I used computers as a kid, but I also was very fascinated by humans and how humans work. So this was sort of an opportunity to combine these interests. So in cognitive science, you try to combine computer science and AI with studies in linguistics and psychology to see what are the commonalities and differences between machines and humans, and how can we design machines and build machines that can interact with humans on the sort of human terms. So that's sort of where my interest started. And then I started to work with this topic of conversational AI, which was extremely small field back then. I mean, the systems didn't really work. I think people remember this horrible system that you could call on the telephone, like SE had a system that you could,
yes.
And it was like always misunderstanding you, even if you just try to speak super clear. So it was a strange field perhaps to enter. And when I went around on like conferences on conversational AI around the world, I felt like we were like 50 people working on this in the whole world. So it was kind of a very, very niche field.
You were ahead of the game.
Yeah. And now a lot of these 50 people are now, of course, working at Microsoft and Apple and so on in these departments that work on this now. So I would never have imagined that it would be as big as it is today. I mean, even 5 years ago, it was more niche, and now it's just everywhere, basically.
So I guess it paid off.
Yeah, in a way. Yeah.
So looking or fast forwarding to today,
Yeah.
did you get answers, or at least some answers that you sought after, and what keeps driving you today?
Yeah, I mean, some people. I mean, the advent of these large language models was, of course, a very big jump in capabilities for conversational systems. So suddenly, we can do things that was sort of inconceivable a few years ago. A lot of the application domains and scenarios that we imagined back then, which were like sci-fi, are very easy to build today. So I think that's that's such a big difference. But when the capabilities sort of come, these new capabilities, new questions arise. So just to give an example, we were sort of excited when the large language models came that now we could build what we called is a companion robot. So a robot that could have a conversation with elderly people, for example, to sort of have as a form of entertainment or how you want to see it. So we built this robot quite early on when the language models were fairly new. And we had this workshop where we invited elderly people and said, sit down here and talk to the robot now, because you could just have a free-form conversation, again, which was impossible before. But still, even though, of course, the language models are very impressive, these conversations were extremely dull and boring. And the language model just asked, like, what is your interest? What do you want to, what you do in your free time? And maybe the person said, I like to read books. And the language model just said, oh, reading books, that's nice. And it's kind of boring things. So then I realized that actually building, even if we can now get it to understand the conversation, you can't really create this kind of engaging conversations. So new questions suddenly pop up. Like, what is an engaging conversation? Right. What is an enjoyment in conversation?
And that has a social aspect.
Exactly. Yeah. So suddenly, it's just new questions. So I think some people think that now everything is solved with these new models, and I don't think that at all. I think it's just new questions popping up.
Absolutely. So I think it's safe to say now that we're not just building features here, but the focus is on making them socially comprehensible. So with the advent of LLMs, something shifted, right? People started treating the systems as, they trusted them more. So when users starts to treat a system, or when do users start treating a system as a social agent rather than a tool? When does that happen?
Yeah, I think that's... There are different aspects when you say social agent. I think one aspect is just that treating it as a conversational partner. And that I think we can do now in a way that we didn't before. You just couldn't understand each other, and you just went into this rabbit hole of repairing miscommunication all the time. Now we can have a sort of a conversation, but there are a lot of different types of social interactions. So some interactions are very transactional. So if you go to buy a ticket or into a store to buy some food, it's a very transactional interaction. It's still a social interaction in some sense, but you know what the purpose is. The purpose is very clear. But when we say social interaction, a lot of people don't think of those interactions. They think about more like relationship building and so on. And those are much harder to sort of define what really the purpose is, and why are we having those conversations. And it also becomes much less clear why we would have that kind of conversation with an AI agent. It's easy to imagine why we would have transactional interactions with an AI agents, but why would we want to build a relation And going back to the experiment that we did with these elderly people, I think that is one of the problems. Like if you say to someone, can you just talk to this agent and have a nice conversation? Like I think the first question that pops up in people's mind is like, why would I talk to this agent?
Right.
Like, what is the purpose of this conversation? I mean, a lot of purpose of conversation is to get to know someone so that you can develop this relationship.
Right.
But you know that I can't really perhaps develop a relationship with this conversational agent, and then it doesn't feel sort of very meaningful. So we always have to go back to the question, why do I have this conversation? Because people always ask themselves that, like, what is the purpose of it?
Right.
And the purposes could be many. Again, could be transactional or sort of relationship building, but there is always some kind of purpose.
And when we do have conversations, I'm thinking about, there's been steady, rapid progress in audio language models now, for example. You can speak with your models and they respond. And they're quite capable today, I would say. But what is the most important micro signal here? Is it timing? Is it coherence? Or what is it that flips the switch for us as humans to feel like this is a natural conversation and I can proceed?
Yeah, I think, I think it's timing partly. It's there. That's still a limitation of even if it's much improving now. But another thing is also what we call back channels in conversations. So back channels are these very short sounds that you just made, like to show that that we are listening. And if it's only a speech, we do this through spoken back channels, but there are of course also sort of visual back channels like nodding and smiling and so on, showing that we're listening.
I just got very self-conscious because I do all that.
Yeah, that's the thing with this job. You have to think about this constantly. Yeah, no. So this is something we do, and the timing of that is super sensitive, like how we produce these things. And you can imagine having an AI model. It has to now continuously process what the user is saying in order to know exactly when should I insert these things. And it's not just doing a back channel or not doing a back channel. How we realize this back channel also matters. So if I just say, it might signal that I'm listening to you, you can continue. If I say, it sort of signals that, wow, that was a bit surprising, right? Or, that's okay, I'm not sure I agree with you, for example. So these very, very small, subtle differences plays a huge role in building what we say is common ground in conversation, which is me knowing, me understanding what you are thinking, and me understanding what you think that I am thinking. So that's what is common ground, sort of, so that we can understand what is our shared beliefs and so on. And this is how we build this common ground, basically, by exchanging these kind of feedback signals. And that's I would say is still, even with all the improvements of these speech models and so on, that's still something I would say they struggle with.
Right. To make it anthropomorphic, to make it feel natural. That statement or that word, anthropomorphic design. Could you please explain that to our listener, what that means? Yeah.
So anthropomorphism is basically just means sort of human likeness. So we can see, I mean, way before robots and AI, we had anthropomorphism in terms of people anthropomorphizing things, which means that, for example, you look at animals as if they were human. You read a lot of intentions into animals that they don't have. So people might think that the animal is more intelligent and thinks a lot more things than it's actually doing. So we're sort of applying this theory of mind that we have with other people. We're applying them to animals, but we could also apply them to objects. So we might think of our car as being sort of an agent.
Sure.
And so on. We get angry at it and so on. So when we build AI agents or robot, we can make this design choice. Do we want to trigger this anthropomorphization of them? Do we want people to think of them as a social agent, or more, as you say, as a tool?
Right.
So we can, of course, if we add all the elements that I mentioned earlier with all these back channels and so on, of course we will increase, or there is a risk or an opportunity, whether we like it or not, that people will anthropomorphize these systems more. So that's an ongoing debate, I would say. Like, is this a good thing or a bad thing? Yeah.
And what's the best argument for it?
Yeah, since I work a lot on trying to sort of build systems that behave a little bit human-like, of course, I think there are arguments for doing that. And I would say the main argument for me is that we know that communication between human feels to most people very effortless. And that's the kind of effortless that we don't feel with technology today in many situations. So if you are at the train station, you would much rather go to a human and ask a question than going to a vendor machine and try to understand how to interact with that, right?
Yes.
It's much more convenient to talk to a human. So there is something super intuitive, of course, which is not strange because all of evolution and our upbringing from when we were very small has sort of shaped us in being able to have this kind of conversation.
So it's based on, it sounds like intuitively just based on trust here, right? Especially for some certain things that you want to add, because I feel it as well. Sometimes I just want to talk to a human because even though I get the same information from both, I think
trust is one aspect, but it's also just that we have this whole, what some research called the interaction engine that we know how to use. So again, being able to use feedback, to use timing in terms of turn taking and all these kind of things makes it very efficient. I don't have to learn how to interact with this entity in front of me. I already know because it's a human being. What if I saw a machine that looks like a human and I can walk up to it and talk to it just like I know that I can talk to to a human? Then that's of course a very intuitive way of interacting with this machine compared to some kind of information kiosk or something. So that I would say is my main argument, is to build a very intuitive interface in the sense that it behaves like a human. I think then comes other things like trust also. Like it could be that I feel also more trust towards it because it behaves like a human.
And that there's some, perhaps, that there's a stake to it. This human, I mean, there's someone, if they say something, they have to own up to it, right? A human, a machine don't have the same.
So I wouldn't say that, and I would say that that's sort of rather a potential problem with anthropomorphism, that we read sort of too much into it. So I would like to read as much as into it when it comes to interaction, to have a effortless interaction. But I don't necessarily want people to always feel trust towards it.
Right.
We don't want to trust. We don't want people to trust technology too much. So to the extent that people would over-trust it, I think that's a failure then of anthropomorphism. But I think that's an empirical question, whether people do that or not. I think one super important thing is that we should always know whether it's a computer or a human we're interacting with. So if I meet a chatbot online, even if it can behave as a human, I want it to clearly state on the label that this is a machine, it's not a human. So I can decide to what extent I want to trust it, not on its behavior, but the fact that it's a human or a machine.
Exactly. And I would even maybe take it one step further and say, all communication, even if it happens through images, say, I remember in the early years of image generation models, when they became really capable, you could have images. You still have them, and videos where you don't know that the communication here is generated and it's not real. And that really creates issues when you don't know when you don't know the source of the information. Absolutely. So that's we could have a whole debate on, or conversation just on that aspect. But let's look at the flip side then. We've talked about positives of anthropomorphism. I assume it can be very helpful for accessibility, learnability, and there's a lot of good things about it. But what is the main arguments against it?
Yeah, I would say one thing is the trust issue that we mentioned. Like we can sort of be sort of tricked to over trust it in a way that we shouldn't. So I would say that then, yeah, that's why it's important to be transparent what it is that we're interacting with. So I think that's one thing, and of course people are worried that apart from trust, you could be manipulated in various ways into behaving. You could be persuaded by an agent that behaves very human-like in a way that you wouldn't want to be persuaded. So we are actually trying to study these things in various experiments where we are looking at the effects of anthropomorphism and seeing if people are affected in these ways. We had, for example, an experiment where we compared a human and a robot, and as a sort of experiment leader. And in this experiment, you were either sitting in front of a computer or a robot or a human, and you were doing various tasks. And one of the tasks was that the experimenter asked how much, saying that you get this amount of money, how much of that are you willing to donate to charity? And we could see that if they were sitting in front of the human, they wanted to donate more money than compared to the computer, which is not so strange because we feel this kind of moral obligation. If a human asks us, like we don't want to sound like we are not want to help people. But of course, the question then is like, where does the robot land? Is it closer to the computer or the human? And actually what it turns out was, in our experiment at least, that the robot was more like the computer. So even if it behaved, programmed to behave in a very human-like way, it seemed like, at least in this setting, the participants were not really feeling morally judged by the robot, which I actually think is a good thing, because I don't want them to feel morally judged by the robot. So I think it's not clear that people automatically are affected by human-like robots in the same way they are affected by humans.
Is it because we subconsciously know that they are, they are constrained into the environment that we are in right now, and there's no social pressure? So what happens in the room in front of the robot, we kind of know that it won't judge us, and we will.
Yeah.
But what happens later if they become interconnected? They are on social media and they're able to speak, So what happens in the room no longer stays there. What do you think?
No, I think then it's sort of different, because then you're actually not judged by robots, but suddenly you are judged by other humans, perhaps watching this. So in this experiment, we were very careful to not record anything. We closed the door. They were basically just alone with the robot. They knew that no human would ever watch me. So I think that makes a big difference. If they knew that there was a human overlooking them while doing this, they might have behaved as just when there was a human in front of them. But it might be that we don't feel these kind of obligations in front of robots, and I think then it's a good thing. Yeah.
Most of us feel like we are thinking in words. So it's inner dialogue, right? That leads our thought process. And indeed, I would say even that we judge the machine's intelligence based on their linguistic elegancy. Something happened with the advent of large language models, and that they blew past what we so-called the turn-taking game, or colloquially called the Turing test.
Turing test, yeah.
Right, the Turing test. But I read a really interesting paper. Language is primarily a tool for communication rather than thought. Really recommend our listeners to read it, which argues something to the contrary, that language is mainly just a communication tool. It is separate from intelligence. It's not you can have intelligence without language. It's not a prerequisite to it. It helps sometimes, but it helps, but it's not a prerequisite to it. So let's start with, why do people, and I think this is prevalent, that people intuitively associate linguistic capability with intelligence? Why is that?
Yeah, I mean, I think it's just the only entities we've had sort of natural language interaction with in the past were other humans who we think of as intelligent, as opposed to animals, for example, or different types of intelligence, at least a different level of intelligence. So it's not so strange. Again, it's this anthropomorphization that if it sort of behaves as a human, we think it also thinks as a human, at least initially, until we sort of realize that it maybe not doesn't. So I think that's sort of the answer to why we would think that language implies thought. But I read this article too, and I think it's super interesting. And I think you say that we sort of experience this kind of inner monologue. But I've also read research where they investigated this thing. They put on a device on people that beeped at certain points in time, and then they were asked to sort of record what their inner thoughts, the inner monologue was, and it actually turned out that in many cases they didn't have an inner monologue at the time. So maybe we sort of overemphasize this sort of perception of language, sort of thought as language. So I kind of, I definitely think that this article resonates with how I see it, that I think language is primarily a tool for communication and not for thought.
So what is the then the purpose of the inner monologue when we do have it? Is it for say memory, or is it attention focusing? Why do we have it? Is it planning?
I think so. So I mean, language primarily is a tool for communication, and the language is built around symbols. So symbols are very efficient way of communicating. So if I use the concept dog, for example, it contains in itself very little information. But when you receive the word dog, you enrich it with a lot of information. Maybe we are talking about the dog and I'm pointing to that and saying, look at that dog. And you use context to enrich that little symbol into meaning a lot suddenly in this context that we are in. Or if I ask you to imagine a dog, you will suddenly start to attribute it with a lot of properties, and you will see this dog in front of you and so on. So language in itself is very sparse with information. It's when we perceive it that we enrich it based on context with information. And so our inner thoughts are extremely rich as compared to these symbols that we're using to communicate with each other. And that's why I think that that was a big mistake, I would say, in the early days of AI and so on, where we're trying to build this kind of intelligence on top of these symbols. So symbol processing, computers. And you could build something intelligent in extremely narrow domain where the context didn't matter so much. But it was impossible to build something broader that could talk across different domains. So it was not until these current LLMs and so on that we can do that don't have this kind of internal symbolic representation, but similar to us, a much richer representation of language.
Precisely. One of the core pieces of evidence that they lay out in support of their argument here is that they point to research that analyzes the language network in brain. So they have MRI scans, right? And they can test on subjects during different tasks and see that this part of the brain that they've identified is silent. There are many tasks that requires reasoning, right? Reasoning, mathematics, theory of mind, other kinds of things. So if we just begin there, could you just explain to us what the language network is and what its role is, so when it actually does kick in? It's not one. If you read this article, you will see very nice illustrations that this language network is actually quite spread out over the brain, but there are certain regions that are more involved when we do language tasks.
And what they managed to do in these studies is to do what you call disassociation, to say that, okay, there are certain tasks where these language networks are activated, but then there are other tasks where they are not. So if you ask people to read a text or listen to someone speaking or speak themselves, that's when these language networks are activated. But you could also see that then there are other areas when they are asked to do logical reasoning or read computer code or do math, when the language regions are not activated. So you find this association then between language use and sort of thinking, even if when the thinking involves sort of symbol processing. So it seems like what the language network, according to this view at least, does is to basically allow us to express our thoughts when talking to others. So they are activating when we are communicating with others, but they are not activated when we are thinking by ourselves. I mean, I guess they could be, but it seems like typically they are not, according to this research. So that's sort of enforces this view that language is used for communication primarily, but not for thinking primarily.
And during your research, what is the most striking example of this? Of something that people assume involves the language network, so to say, but in reality it doesn't.
Yeah, I should just say that it's not my research.
No, but just like in your in your experience.
I mean, I haven't studied this specific dissociation myself, of course, but it seems like according to this research, at least, like the examples I had before, like I would say reading computer code. I think many people would intuitively think that would involve these kind of language regions or language processing. So that to me was one surprising thing.
And as you mentioned, they point out this concept of double dissociation, right? Thought can survive language damage, and you can have linguistic capability, and in certain situations be impaired in your reasoning capabilities. They have a lot of sources, but I thought some were interesting that might be for the listeners. So, for example, they've seen that in kids that are born deaf, and with parents that are at the beginning at least unable to speak sign language, then these kids don't get any linguistic inputs, but they can still show what they've shown is that these kids still learn rich information about the world and how the world works and how things connect to each other. So they can reason without actually being learned to converse, so to say. And then you have also cases, certain conditions for people where their linguistic capability is relatively intact, but they are unable to reason for tasks. So the claim that language doesn't matter for thought, what does that really mean? Does it mean that it doesn't matter at all, or does it mean that it matters in a different way than we might have intuitively just think?
Yeah, I think that's still open for debate, like how much it's actually involved in thought. And especially if you talk about, I mean, it's one thing with language. Another thing I think is what I talked about before, which is like more symbolic reasoning. So that's one argument that people have now, is that this is something that LLMs are not necessarily very good at, to do more sort of symbolic reasoning. And if you train it on patterns like A is B and then ask him is B A and so on, these kind of logical relationships that follows from logic, they don't necessarily understand those kind of things. So that's, I guess, a bit of a debate. Like some people are arguing for more sort of neurosymbolic approaches and so on. So I think the discussion is more there. Like, do we need more sort of symbolic reasoning? And it's important to remember when it comes to large language models, they are trained on language, but the internal representations are not symbolic in the sense that language is, right? So the transformer, it takes these words and transforms them into representations that are highly context dependent, sort of a little bit like we do as humans. So internally, it's actually sort of not language anymore in the sense that language, this kind of symbolic language we are thinking of typically. So of course then we use them to generate language and so on to predict the next token and sort of have this generative process. But internally the representations, I would say, are not really symbolic, at least.
No.
But then they kind of use language in the sense, if you do this chain of thought or you use reasoning models, they are generating language and then consuming their own language that they generate. So they have this kind of internal language thought. Maybe that is similar to what we experience as humans, that we do sometimes, that we have to sort of express our thoughts in language and then listen to ourselves, to our own language, in order to sort of create richer thoughts for ourselves, which is, again, a little bit similar to what the language models are doing. But there's also research suggesting that you can actually do this kind of chain of thought reasoning purely in this sort of more latent abstract space.
Right.
You don't necessarily have to go through language. But I would say most of this, of course, very open question still.
It is, and there are, I was about to say two main camps there, but there are probably several. Some believe that language really is all you need, text. And then you have others that say that, perhaps multimodality will solve it. So it's a very, very interesting debate going on. So if you want, let's assume that the inner monologue is sort of your private code to help you reason. And not the driver of it, but just it helps you. I think looking at language, one piece for me that is evidence that language is not intelligence, or that is just a communication tech, let's say, is the way that language changes. You can see now, I'm starting to get a little bit older. I would say I'm still young, but still the slang, or these that the young generations use now, and this, they tend to simplify. And it's quite contextual to the generation. They understand it. So, for example, let me give you one example that I noticed when I was in high school even. And in Swedish we have de och dom, right? They mean different things. And by using both of these, you can convey to the reader a different sort of information, right? You have granularity there. But now, colloquially, you start to use one word to describe them both, dom, istället. And you even spell it the same way. But they lose a sort of the information conveying capacity there. So for me, that is sort of an evidence that they use it as a sort of language is used as a communication mechanism rather than the most efficient way to transfer information or thoughts. So what is your take on this? Do you agree or?
Yeah. No, I think language is I think everyone uses language in as efficiently as they can. So language is designed to be efficient. As I said before, like symbols, which is what we use to communicate, are an extremely efficient form of communication, a very robust form also. It doesn't matter exactly how I pronounce the word dog. You will still sort of map it to the same underlying concept regardless of my exact pronunciation. And then you will enrich it by context. You will think, why does this person want to tell me this? So you are trying to always sort of add this sort of interpretation layer on top of it. And when two people know each other, the more they know each other, the more efficient their communication will be. So the less symbols they have to exchange in order to understand each other. So if you watch two young people communicate, you might think that it's gibberish, or that it's just some exchanging a few words, and to them it means a lot. But to an outsider, it really doesn't matter, because we don't have the context that they sort of thought that the listener was supposed to have to understand what they said. So communication is always between two people, or at least two people, where the sender have a theory of mind of the receiver and designs the message as efficiently as possible for the receiver to be able to pick it up and enrich it with their context. So I would say that language is sort of almost by design a very efficient form of communication, as long as we are good at theory of mind. Of course, if we are not very good at that, then language becomes inefficient. Or if we don't know each other very well, we have to use a lot of inefficient language use. So I would say it's sort of inherently an efficient way of communicating.
Right. One big change now is, again, everything happened during the last couple of years, is how we move forward, and how people know things. So we're moving steadily, rapidly from systems that helped us, search or recommend, and just give us the documents, and allow us to put our judgments into the conveyed information, into instead moving to generative systems that through retrieval augmented generation or what have you, different techniques just provide you with a synthetic answer, aggregated synthetic answer. In one way, it's efficient because it makes information that you're looking for easier to evaluate. It just puts it in front of you in an aggregated way. You don't have to search for it yourself. You just have it. Here's the answer, right? But what happens? What is the biggest? What is the biggest risk of AI? And this, I've thought a lot about this. What if the biggest risk to AI is not having them provide you with incorrect answers, but making us lazy and just make the evaluation of information easier?
Yeah, I think that is a big problem, actually, and I think we are fooling ourselves sometimes into thinking that we have done something, a piece of work, because we let the AI do it, and we haven't really. And of course, this is hurting the most in education, of course, for students who sort of use it for their homework and think that they have done. And of course, the purpose of the homework was not to write this essay, because nobody will read this essay apart from the teacher. So the purpose was learning. And if you didn't write it yourself, you didn't learn anything. So, but actually, I think that applies to a lot of what we are doing in daily life. We learn every day and develop our thinking and so on. So getting everything pre-packaged for us, I think, is detrimental in the long run in sort of developing our thinking and understanding further. And of course, someone could say that sort of, yeah, but now we have AI, so we don't have to sort of develop our thinking. But I don't think that's true. I think one of the hard things is not knowing things. But sure, we can ask AI to give us answers, but the hard thing is to ask the right questions and
understanding things.
Understanding things, because in many jobs, I mean, in academia, of course, asking the right questions is essential. Like that's what you do as a researcher, is asking the question. And once you have come up with the right question, then you can actually answering it is the easy part in a way. But that goes for a startup, for example. It's also about asking the right question, like what problem are we trying to solve? And this, I don't think AI is very good at. It's good at providing solutions to problems once we have asked the right question. But I'm not so sure it's very good at that aspect of asking the right question. So that's where we are. If we are not internalizing all this knowledge, if we are just outsourcing everything, we are not gonna be able to ask those questions, I think. So I think that's the big risk. If we are not internalizing things, we are sort of losing that capability.
And the risk, I think, is we're if we don't do anything about it and just go all in on this, is that we will move towards a future which is more and more technological, but less and less people understand it.
Then you have this sort of situation where my AI agent is talking to your AI agent and so on. I don't think people want this kind of scenario. I don't think people, when you ask a question and you get answer, or sort of if you would post on social media and you get AI bots commenting on your post, like that's not satisfying, right? You want humans to do that. So even if the comment is sort of on the surface exactly the same, you want to know there was a human there reading it, right? So I think we will still want to have humans to interact with, So I think this idea that you talked about in the beginning of sort of this vision of sort of us being surrounded by AI agents, sort of replacing other humans, I don't think people want this. So I'm not so sure that's how the future will turn out.
We're seeing, I mean, there's, of course, there's commercial interests for companies that are pushing for this, but there's pushback. There's more and more pushback now. You're seeing it in arts, for example, in many fields, but in arts as well. How much do you actually value? How much do we actually value? It was cool at first when you see it the first time. Oh, there's a nice video or an image. But then, what's the purpose of it? If everyone can just, there's been no effort in creating it. No. There's no history. And it's mass produced. So I think this is one of the most important questions that we need to figure out. How do we actually co-live with this technology that still makes life, meaningful for us, and we don't get overwhelmed. If we look at our science fiction movies, we see people, different types of movies. They coexist with AI. I just wonder how they got to that point. So, for example, Star Trek, they have bots on the bridge. So how do we get to that point? This omnipotent AI that knows everything, but still it's not there to take over. So there's a lot of, there's a big questions we have to decide together as a society of how we want to coexist with this technology. Right. So I read another really interesting paper about epistemological fault lines between human and artificial intelligence. So what they do is they talk about different ways and the differences between human cognition and communication and robotic communication and cognition. So when we talk, our words are anchored in a shared word. Our experiences, who we're talking to, social pressure, everything is there. And we can probably point to evidence. There's more stake to it when we talk to each other. But as you mentioned as well, that machines don't really do this. They are trained on basically big statistics. They embed their context, and then they're trained to always respond with an answer. So what does that mean for a robot then to know something? If their knowledge is not tied to the world with the context the same way as perhaps ours is that assumption even correct?
I'm not really. I think in certain limited contexts, at least, you could say that a robot's understanding of the world is sort of, I would say, adequate for the task that you are doing. I think they go a little bit too far in that article in saying that this is like impossible for AI to anchor its understanding in the world. I think it is possible to some extent. I think current LLMs have some understanding of concepts and so on. And I think if you train it more and more on like multimodal data and
I was just going to ask, do you think that will alleviate the problem?
I think it's kind of similar that it will have some understanding, but of course then the next question is like, it's one thing to sort of understand the world or understand something in the way that you can sort of, for example, summarize a text or summarize a situation and answer questions about it. The other thing is to be able to engage in an activity and taking actions in that activity. So if you have a robot, in a very limited domain, like it's working in my kitchen and filling my dishwasher and so on, I think it's realistic to think that it can form a good enough understanding eventually of my house and my kitchen to do those tasks. I think it's a different thing to create an agent that can be part of an organization and understanding that kind of level of sort of deeper understanding of context and the activities and so on. So I think that's, again, it depends on like how big is this context we're talking about. I think as long as we're talking about constrained context, I think it's realistic to think of these LLMs as having a sort of good enough understanding of that to be meaningful as sort of conversational partners or as job partners and so on. But I have a hard time seeing them grasping this kind of huge context that we as humans are able to understand and navigate and deciding what to do and building new projects and so on.
Right.
Yeah, so that's sort of my view on it. Yeah.
Very good. They do make a quite important definition, epistemia, and that is linguistic plausibility, substituting for epistemical work, right? So without knowing, but it's linguistically plausible. So this pose a I think interesting psychological question about users. So do they start behaving differently when the system, the linguistic capability becomes plausible? If one concept say do place more trust in it, and it's warranted, like what happens psychologically?
Yeah, I think it ties back to the earlier question of like when we get sort of thought processes served to us and we believe that it was our own thought process, but it wasn't really. It was just pre-processed for us. So I think that's a mistake that is easy to make, believing that we have reached an understanding, but that we haven't reached ourselves. I think that's what they're hinting at in this distinction.
If you could add one feature to alleviate epistemia when robots, when they're user-faced, what would that be? Would it be some guardrail, or what would it be?
Yeah, I don't know. Like, I don't know if it's possible to engage in conversation with people to make sure that they have understood things. I mean, now I think in general agents don't, like if you ask ChatGPT to do something, it typically just goes and does it and summarize it and you have to correct it if it does something wrong. It doesn't really engage much in conversation or trying to clarify things and saying, what do you actually mean by that request? What do you actually want to accomplish and so on. These kind of, it does a little bit of that, but not what a human would do. A human, if I would ask someone to do something, I want them to ask me questions back and try to understand where I'm coming from and what is the purpose of this request and so on. So that goes back to the sort of being able to have that kind of dialogue to reach some form of common ground before we sort of proceed with the next step and not just guessing that maybe this person wants me to do this.
Right.
So I think that's something that I think, we will have to look more at building this common ground and making AI agents be able to take initiative to build that common ground.
Interesting. So that goes back to, now we're talking about metacognition then, because if you have, let's say honest humans at least, if they don't know, they can take a step back and they will say, you know what, I don't know this. But our language models, they are incentivized to always answer. Yeah. And this was a big problem, prominent problem. Got mainstream, like, they will always answer and they will sound confident. And confident, when they sound confident, we trust them more.
Yeah.
nowadays we have you can add on some reinforcement learning from human feedback and get systems that sort of say I don't know sometimes, but I still don't think we are there. So this concept I don't know and taking step, how would that look? How would that ideal look for machines?
Yeah, I think that's actually quite a big has always been a big challenge in computer systems and AI. I mean, typically an AI is trained to classify things as being, and we had these problems early in speech recognition as well. So, which is the task of just turning speech into text. So, whatever you put into the system, it will output some text, even if it's just gibberish, because it was just trained to guess what is the most likely thing that the person said. So the systems are trained to select among a set of options rather than perhaps saying, I don't know, I don't have an answer to that. And of course you can train them to do that, but it's actually very hard because you need to have some kind of background model of saying that this wasn't actually speech, this was something else. And this something else could be so many different things. And for us as humans that have all this experience, we can easily map this thing that we heard to something else that we have experienced. But these systems are often they're not trained in that way to sort of. So, of course, yeah, I guess what's happening now is that they are trying to train the system to ask questions that are unanswerable and try to train them to then sort of say, I don't know. But I guess the problem is that the set of questions where you should say I don't know is so huge.
Right.
Like it's a huge space. So I think that's why it's such a hard problem to be able to know what you don't know, basically.
Precisely.
Yeah.
And are we any near solving that?
I don't know. I mean, I think systems today are better than they were a couple of years ago. I mean, they hallucinated all the time if you ask something, made things up, and they are better at not doing that now, but they still do. So I think it is a problem, and I think it's something that we as humans have to learn how to interact with the systems and understand that when can we trust them and what types of questions can I trust them with and what type of things can I not trust them with. So it's a little bit up to us also to adapt.
Time really flies.
Yeah.
We've covered a lot, Gabriel. We talked about social robots, anthropomorphism, benefits, risks, current challenges, epistemia. But let me end with a quick lightning round. Just what is one thing that people misunderstand about language and intelligence?
Yeah, that's a. Well, we have touched upon so many of these questions. I think one thing. I mean, the interesting thing with large language models is that we got these models that are sort of more intelligent than anything we had before, at least, by training them on language. So that ties back to the question we talked about earlier. Like, if now language is not, if thought is not about language, how come we got these intelligent models by training them only on language? Like, that's sort of a paradox. And that I think we have to understand that they are trained on language, but the representations are not necessarily sort of linguistic. They are this kind of very enriched representations based on context that they form. So this paradox, I think, is something that is sort of puzzling us a bit when trying to understand this relationship between language and thought.
And what is one open research question that you wish people were more aware of?
Yeah, I think, again, I think the open research question for me is where I started a bit, is like we sort of, it's easy to think that we have sort of solved a lot of these questions about how to make a machine that can have a conversation with people. But I think we haven't really, what we haven't really solved is how you can have a kind of meaningful conversation in a lot of the domains that we will find robots on in the future, and how we can build this kind of meaningful conversation with robots and AI in general, in all the kind of domains that we don't have today. Today we have it with things like ChatGPT and so on, but that's actually a highly constrained domain with very specific tasks that people typically use it for. So going back to, is it actually possible to build a robot that would act as a sort of a companion? That still, to me, is sort of left as a problem that we don't really know how to do. Yeah.
Gabriel, thank you very much. This was very interesting. And one takeaway for the listeners here is that social AI is not just about capability, but it's about how humans connect with them, how they interpret them, and how they depend on them. And therefore, every design decision we make matters. Thank you very much, Professor.
Thank you very much.
My pleasure.